Hello everyone, welcome to PE Academy. So in this video we are going to be looking at Ohm's law. So we are going to be looking at what the laws are. We're also going to be looking at the formulas that are related to Ohm's law. We are going to be looking at different examples under Ohm's law. So if you are new to this channel or you are yet to subscribe, you can kindly click on the subscribe button and the little bell icon beside the subscribe button. So what we have here is the Ohm's law. It says the current passing through a metallic conductor, e.g. wire, is directly proportional to the potential difference across it, provided that the temperature and other physical conditions are constant. So what does this mean? It says, let's look at it one more time. The current passing through a metallic conductor, it says what is directly proportional. Now this is what it said, the current passing through metallic conductor is directly proportional. Let me underline this word, directly proportional to the potential difference across it. So the current is represented with I, the potential difference V. So now let's bring it out. It says the current is directly proportional to the potential difference. So we can have that as V is directly proportional to what? To I. V is the current, is the potential difference, and then I is the current. So when we have something like this, we can write it as V is equals to Ki. Now here where we have K is our constant of proportionality. Now this is our K. So we can have our K is equals to what? Is equals to R, which is resistance. So now if we should replace what with this K with this R, we'll be having V is equals to Ri. So we can write it properly as V is equals to IR. So this is a formula that you can use to get a voltage. So this is one of the formula that you can derive from the Ohm's law, which says the current passing through metallic conductor, e.g. wire, is directly proportional to the potential difference across. So we can also look at it, this Ohm's law from this angle. Let's have this to be our wire. So let's look at the Ohm's law. Like I said, the current passing through a metallic conductor is directly proportional to the potential difference. So now if this represents a wire which is a conductor, and then we have currents passing through this wire. Now if we should increase the potential difference across this wire, an increase in potential difference, so if you have an increase in potential difference, that will result to an increase in the current. So that is what the Ohm's law is saying. We are going to be seeing more of this when we start to do example. So if you have a circuit and then you increase the potential difference, then there will be an increase in the current that is passing through in that circuit or through that wire, using this example that we are looking at. So the formula V is equals to IR is one of the formula that is associated with Ohm's law. So now we are going to rewrite it to make I the subject of the formula and then R the subject of the formula. So with this now we can easily calculate using this voltage is equals to current times resistance. So if we have the current and then we have the resistance, we can easily calculate the voltage across maybe a circuit or a metallic conductor. So using voltage, V is equals to IR. So this is V is equals to IR. So if you make current subject formula, that means current is equals to voltage over resistance. And then if it is resistance you are looking for, that is voltage over current. So let me also add the units. So okay, the unit for the voltage is in volts, current is in amperes, and then resistance is in ohms. So just take note of that. Once you start doing example, you'll be seeing using the units. So you can take note of this formula. This is the formula that is related to Ohm's law. So now let's start to look at examples that we are going to be applying these formulas. So here's example 1. It says verify that the current through a 10 ohm resistor increases when the voltage is increased from 5 volts to 30 volts. So let's look at this example under Ohm's law. So if you remember Ohm's law, that when I said the current passing through a metallic conductor, example e.g. wire, is directly proportional to the potential difference across it, provided that the temperature and other physical conditions are kept constant. So basically what that means is that once you have, like I explained earlier, if you have, let's say this is a wire, and then we have an increase in the voltage across this wire. Once we have an increase in voltage, then definitely we are going to have an increase in current. And that's what this question is saying. It says verify that the current through a 10 ohm resistor increase. So look at this word, increase, when the voltage is increased. So they are just asking us to, let's check using that Ohm's law to see that what would happen if we increase the voltage from 5 to 30. Will the current also increase? So that's what this question is talking about. So first thing we are looking at, let's bring out the parameters. We are given that the resistance is what? The resistance of the resistor is 10 ohms. And then we have the voltage to be 5 volts, and then it was also increased. The initial voltage is 5, it was increased to 30. So let's look for the current. So let me write this as our V1 is 5 volts, and then our V2 is 30 volts. So what we are calculating for now is the current when the voltage is at 5 volts. We are also going to be looking now for the current, which is I. So when the voltage is at 30 volts. So now let's bring out the formula again. We have it as V is equals to IR. So if you have V is equals to IR, since we are calculating for for I, which is the current, so our I is equals to voltage over resistance, that is V over R. So now let's look for the first one here, which is, let's calculating for I1. So our I1, which is the current when the voltage is at 5 volts, is equals to, that is V1 over R, that is 5 over 10. So our I1 is equals to 0.5 amperes. So now we've gotten our I1, which is the current when the voltage is at 5 volts with a resistance of 10 ohms. We've calculated it and we've gotten 0.5 amperes. Now let's now verify if the current will increase now that we have an increase in voltage. So now let me write this as, so right here we are calculating, so we are calculating for I2. So I2 is equals to V2 over R. So let's put in our figures. So our V2 is 30 and our resistance is 10. So that was 30 over 10. So we'll get our I2 is equals to, so 30 divided by 10, that will give us 3 amperes. So you can see that our current has increased from 0.5 amperes to 3 amperes. So that's to tell you, this is just to verify Ohm's law, that once there is an increase in the voltage, we have an increase from 5 volts to 30 volts, you can see it results in an increase in also in the current. You can see the current also increased from 0.5 amperes to 3 amperes. So that is it. So the solution to example 1. So we are going to be looking at another example in example 2.